Okay, in this session we're going to look at some constructions questions as opposed to loci questions. So before we take a look at them, let's go through the standard things that you need to be able to do. The most basic construction is a 60-degree angle. So if we start with one of those, if we just draw a line, and let's say we want to construct a 60-degree angle from this point. You get your compass, you would open your compass out, it doesn't matter how far, don't want to make it too large, and draw an arc of a circle. You would then move your compass point from the corner where you want the angle to be drawn from to where that arc crosses the line. And you would then draw a second arc to cross the first. When you then join the corner you want the angle to be drawn from through the intersection of the two curves, that will give you a 60-degree angle. So that's a 60. If you want to draw a 30-degree angle, then you would need to bisect that. And bisection is a second construction. So if I draw a 60 from this side, and if I draw it down just to make myself a bit more room, so I'm going to move the compass point to that end and draw an arc underneath the line like that. Then same deal, I'm going to cross like that. That will give me, as we now know, a 60-degree angle. So if I just plot that in there, that would be 60. To bisect the angle, what we do is where this line crosses, this arc crosses the line here, I'm going to extend the arc out into the middle of the angle. And then I'm going to repeat that process from here. So I've got again a pair of intersecting arcs, and when I join those, what that will do is cut that original angle in half. So this angle, or that angle for that matter, will be 30 degrees. So to construct a 60-degree angle, which is your basic building block, you do that. If you want a 30-degree angle, then you would bisect that angle, and this method works for any bisection. Now where an exam question is telling you to use compass and ruler, then this is what the examiner is looking for, are these arcs, these intersecting arcs, the construction points. Without those, the examiner cannot award you the marks, because he has to assume you've used a protractor, an angle measurer, in order to find those angles. So that's a 30 and a 60. The other one that you're often asked for is a 90. And with a 90-degree construction, basically what you're doing is bisecting 180 degrees. So if we have a line like that, and we want to draw a 90-degree angle there, what we would do is extend that line somewhat, so we've got a straight line to bisect. So what you would do is you would get your angle measurer and make a pair of crossings like that, and then this time what you need to do is open out your angle, your compass, a little bit further, otherwise you end up just going back to where you started, and again a pair of arcs from each of these intersections. So there was your starting point, there's your 90 degrees. If we do it from this side, so if that's where we want our 90 degree to come from. Extend your line, compass point where you want the angle to be drawn from, intersect, oops, intersect, make your angle a little bit larger, not your angle, your compass radius. And there's your 90. So we've got 30, we've got 60, we've got 90, we've got a bisection of an angle. In loci, and I've done plenty of videos on loci, if you need to bisect a line, let's say we want to cut that line in half with a perpendicular bisector, this is where, when you open your compass, it needs to be over halfway. You need to cross the halfway line, so make that visible, and then you want these arcs on both sides of the line. Move your compass point to the opposite side of the line and repeat that, and then to construct your perpendicular bisector, you would draw a line through the pair of intersecting arcs, and what that does is it cuts that line exactly in half and at right angles. So that's a perpendicular bisector, 90 degrees, 30 degrees, 60 degrees. Okay, let's take a look at these questions. Who has designed a new clothes hook? He has made a rough sketch as shown below. Use a pair of compasses and a ruler only to construct an accurate drawing of Hugh's design. You must show all your construction lines. Okay, so 8 centimeters. Let's make sure we've got plenty of space. So can I fit this in? If I zoom out a little bit. So if I start down here, and I'll use a pen, but use a pencil in the exam. So it's an 8 centimeter base. So there's my base. I need to construct 60 degrees from this corner. So get my compass. Arc. Move the compass point to the intersection. Second arc. And I need to go 9 centimeters along there. So if I line the 0 of my ruler up with that corner, send the ruler through the intersection, I know that I need to go up as far as 9 centimeters, which is there. So this is 60 degrees. This is 9 centimeters. This I measured as 8 centimeters. So now I've got the 90 degree angle to construct from there. So from that point I need to continue my line. So I'll do that as a dotted line to show it's not part of the actual drawing. Arc that side, arc that side, open the compass further, move the compass point to the second arc intersection to draw the second arc. So this time I know that my line has to start at there, so line the 0 up there, go through the intersection, and it's 5 centimeters in that direction. So that's a right angle, and this is 5 centimeters. So there you go. That is what they're looking for. The clear construction lines. So they call them construction lines. In fact, they're not lines, they're arcs, parts of circles, but that's what gets you the marks. So let's just have a look at the mark scheme. So you get 1 mark if it looks like that and your lines are all correctly measured. We'll give you 1 mark. There are 2 marks for the 60-degree angle. So lengths, 60-degree angle, 2 marks, and 2 marks for the 90-degree angle. So that's how the 5 marks are awarded. Okay. Question 2. Diagram below shows a freehand sketch of a triangle ABC that is not drawn to scale. Use a ruler and a pair of compasses to draw an accurate diagram of triangle ABC. Line AB is drawn accurately for you. So that's 12. I'm not given any angles in this, so I'm not going to be constructing angles. What you need to do is to, in order to work out where point C is first of all find what is 9 centimeters away from A, and you do that by drawing an arc of a circle with a radius of 9 centimeters. So you get your compass, point on 0, open it out to 9 centimeters, put the compass point on A and draw an arc of a circle. What this is doing is saying that line C, point C, is going to be somewhere on that curve, because at every point on that curve you are exactly 9 centimeters from A. We're interested in the point that's not only 9 centimeters from A, but is also 7.5 centimeters from B. So now I go back to my ruler and I open it out so it's a radius of 7.5. Put the compass point in B and draw an arc from B. Everywhere on that arc is exactly 7.5 centimeters from B. So where the 2 cross is going to be the one point which is both 7.5 centimeters from B and 9 centimeters from A. So point C is there. So when you're constructing your triangle, that's what it's going to look like. So there's only 2 marks for that. Basically, 1 mark would be for the construction arcs, or both marks if you get the construction in the right place. 1 mark if one of the sides is correct. Question 3. McReardon Construction is contracted to work on a warehouse site where there are a number of liquid storage tanks. A sketch of the base of one of the liquid storage tanks is shown below. 333, so it's an equilateral triangle. Use a pair of compasses and a ruler to make an accurate scale drawing of the base shown above. Use a scale of 2 centimeters to represent 1 meter. So if 2 centimeters represents 1, 4 centimeters will represent 2, 6 centimeters will represent 3 meters. So that is going to be on my diagram 6 centimeters, 6 centimeters, 6 centimeters. Now it's an equilateral triangle, so I know that all the sides are the same and all the angles are the same and they're all 60. So you could construct 60-degree angles here, but there's no need because we can do this in the same way as the previous question, where we just create the arcs 6 centimeters from the base. So if I draw myself a 6 centimeter base. Then get my compass, open that out to 6 centimeters. That arc is 6 centimeters from that edge. That arc is 6 meters from there, and where they cross is the top of the triangle. So you don't need to actually construct the 60-degree angles there because you're given the lengths of the sides. Part B. McReardon Construction has been asked to lay a drain surrounding a different liquid storage tank. The drain must be exactly 2 meters away from the perimeter of the base of the tank. An accurate scale drawing of the base of this tank is shown below. A scale of 1 centimeter to represent 1 meter has been used. On the scale drawing below, draw accurately the position of the drain surrounding the tank. So, exactly 2 meters away from the perimeter on the outside. So the distance here needs to be 2 meters away, 2 meters away, 2 meters away. The complication is what happens at each corner, because at each corner that 2 meters creates an arc of a circle. So I'll show you what I mean. So 1 centimeter to represent 1 meter, so 2 meters is going to be 2 centimeters. So we need to open our compass out to 2 centimeters. What we do then on each of these corners is draw parts of circles. So at those corners we're going to have this curved part to the distance, and then between the corners we have the parts that are parallel. So exactly 2 meters from the straight sides you're going to have a line that is parallel to it. Same with that one, it's parallel to there. Same with that one, it's parallel to there. But then when we reach the corner from there around to there, it's no longer parallel, because as soon as you move from there you're actually further from that point. So it then becomes an arc of a circle around that point until we run parallel again, and then we get an arc of a circle around that point, and then we run parallel again. So that's quite a complicated little locus question. Okay, it's not so much constructions on its own, it's a loci question. So the marks for that one. 1 mark for the 3 green parallels. There's 1 mark for recognizing an arc on the circles, on the corners, and there's a mark if you've got it all right. Question 4. A tile maker needs to make an accurate drawing of a regular hexagon. The length of each side of the hexagon is 4 centimeters. Draw the hexagon accurately below. You must mark on your drawing the size of each angle. So this one isn't actually a constructions question. You can use a protractor on this, if I can find one. It doesn't say construct, it doesn't say use a compass. So a hexagon, what do you need to know? Well, you need to know a hexagon has got 6 sides, and you need to know how to find the internal external angles of a hexagon. The external angles, hopefully you'll know, is 360 divided by the number of sides to find the exterior angle of any polygon, which is going to be 60 degrees. The internal angle is going to be 180 degrees less that, which is 120 degrees. So if we just do a little sketch to remind ourselves what this should look like, it's a 6-sided shape. So it's going to look like that. These external angles are 60, the interior angles are 120. So that's what we're going to be measuring. So if we start at that corner, if I line my angle measure up with 0 over there, I'm going to be measuring the interior angle, so I'm going out to 120 degrees. Alternatively, if I lined my 0 up over there, I'd be measuring the outside scale to 60. Doesn't matter so long as you're clear which way you're working. So since I'm here now, I'll mark the 60 degrees, and I need 4 centimeters along there. So if I go, so what I've done there is I've lined up 8 with that point, so I'm going to go as far as 4 there. And then if I just extend this, I probably, no, it should be right. So now I need 60 or 120 from there. So I've lined the center of the protractor up with the corner of the vertex that I'm measuring from now. 0's on the outside, so I'm working with the exterior angle of 60, which takes me to there. And again, what I need is 4 centimeters, which is to there. I'll keep it going a little bit further for the next line. So 60 degrees takes me to there. Line up my 8, go back to 4, keep it going a bit further. Still working with exterior, 60 is there. Line up the 8, back to 4, keep going a bit further, and then the final one should take me back to the start. It's a little bit out, but it's probably out because that isn't exactly 4. No, as you can see, what's happened here is that the size of that shape has been reduced in printing the question out. So it's going to be a little bit out, but that will take it back to the start. So as you can see, it doesn't look perfect because that wasn't 4 to begin with. 5 marks for that question. 2 marks for working out interior or exterior or both, whichever one you're going to work with, and then 3 marks for the actual drawing. 1 mark if you get 4 of them correct. 1 mark if you get all of them correct, 1 mark if everything's correct. So there you go. Constructions.